You've captured a great example of the specialized signaling required for maritime and road traffic to coexist. The setup at the Daisies Pass River Bridge, likely a fictionalized or edited name for a bridge in the Florida area, shows exactly how high the stakes are for drawbridge safety. Why this setup is unique. As you mentioned, the Manual on Uniform Traffic Control Devices, MUTCD, is strict about drawbridge signals because a failure to stop isn't just a fender-bender risk, it's a life safety issue. The confirmation light, that blue light, sometimes called a telltale, hanging on the span wire is a clever piece of engineering. It allows the bridge tender to verify that the traffic signals are actually functioning and showing red to drivers before they begin the physical opening sequence. Transit signal heads, seeing horizontal bar signals, typically used for light rail or buses, mounted on the concrete pole alongside standard traffic signals, is indeed rare for a bridge. These are often used to give specific instructions to transit vehicles that might have a different stopping point or priority than standard car traffic. Dual primary heads, the MUTCD, requires at least 2 signal faces for the approach to ensure that if one bulb/LED unit fails, the stop command is still visible to oncoming drivers. Signal breakdown. Component. Purpose. Span wire signals. Provides high visibility red/yellow/green for main roadway approach. Blue telltale light. Visual confirmation for the bridge operator that the signal is red. Pole-mounted transit heads. Specialized signals, often lunar white bars, for transit-specific movement. Warning beacon. Positioned further back to give heavy vehicles extra time to brake. It's a great catch. Most people drive right under these every day without noticing the redundant safety systems keeping them from ending up in the water. The details you provided about drawbridge preemption perfectly describe how complex intersections near waterways maintain safety and traffic flow. How drawbridge preemption works. Much like a railroad crossing, a drawbridge preempts the normal signal timing to prioritize safety and clear the track, or in this case, the bridge approach. The flush-out interval. As you noted, the system first triggers a flush where traffic moving away from the bridge gets a green light or arrow. This ensures that no cars are trapped on the bridge or between the gates and the intersection when the span begins to move. The prohibited movements. To prevent a massive backup that could block the intersection, the controller uses blank-out signs or red lights to stop any movement heading toward the bridge. Your image clearly shows this with a green arrow for a safe turn, while movements toward the bridge are restricted. Long-duration openings. If a bridge stays open for an extended period, typically 10 to 15 minutes, switching to a flash mode can be a failsafe to prevent motorists from becoming impatient or assuming the signal is broken, though this varies by local agency and controller programming. Key components from your descriptions. Feature. Function. Blank-out sign. Immediately displays restrictions, like no straight, when the bridge cycle starts. This level of coordination is vital in states like Florida, where high traffic volume meets heavy maritime activity.